All right, you're good to go now.
Awesome. So as I said, I'll be talking mostly about MLlib, which is PySpark's or Spark's ML library, and then a little bit about MLFlow, which has a number of cool functions. In fact, and I'll speak mostly about ways to log your models so you can very easily keep track of what you've done, because like I'm sure you've run into this, that you're running a lot of different models with different parameters, potentially with different data sets as they're coming in. And if you don't have a good way to track that, it can get a little bit messy. So I'll talk about, how to prepare your data in PySpark for use with MLlib, how to train and evaluate several classifier models. MLlib has a whole bunch of other models too. I just chose classifiers because they're familiar. So you can see what it looks like in comparison to sklearn, for example. And then how to log model performance with MLFlow tracking. So what you'll need is PySpark installed if you want to follow along, or I'm running it on a Docker container. The specific Docker image that I'm using is in this GitHub repo that I've shared, as other notebooks. So you can absolutely run it on Docker. And additionally, you'll need MLFlow. So why PySpark? I mean, Ted has really said this already, but enables scalable analysis, but without having to know Scala or Java, which is what Spark really runs on and has often been a hurdle for people coming in with more of a Python background or not typical computer science background. So PySpark allows you to use the functionality of Spark from within Python. And you can use distributed processing. So really great when you're working with really very large data sets. You can also create ML pipelines with PySpark, very similar. In fact, I think it's modeled off of sklearn's pipelines. So the same idea of fitting and then transforming your data so that it's very easy to make sure that you do the same things on your training data as your test data. And it keeps your code nice and neat. And you can interact with pandas. So you can cast your data to pandas if you want to have a quick look at it. MLlib is PySpark's machine learning library, and it's got a variety of classification and regression models in it, including linear and logistic regression, tree-based models, so plain decision trees, random forest, gradient boosted trees, multi-layer perceptrons, naive Bayes, clustering algorithms, collaborative filtering, and frequent pattern mining. So it's got a fairly good connection. And as I mentioned before, Spark really works on this pipeline workflow where you have a data frame from Spark SQL that can hold a variety of data types. And typically you have to transform those to have your features together in a dense feature vector to be able to use for MLlib with your labels separately. And that works through a series of transformers, which a transformer is really just an algorithm that can transform one data frame into another data frame. Think scaling string to vectors or to indices. And then after transforming, it's got estimator instances you can fit then on that on a data frame to produce a transformer. And the pipeline ties it all together. And as we jump into the notebook in a moment, I'll show you these different steps again. So things to note before I jump over into the Jupyter Notebook. As I said, for MLlib, your data has to be in a dense vector format, so you can't have separate features for input into the model. You need to transform it first. Like many other machine learning models, most, I guess, your data has to be numeric. So any text data needs to be tokenized, vectorized, so that it is in numeric format, and it has to be 0 indexed. So your label, for example, can't be 1 and 2 if you're working with a heart disease, which is the data set that we're going to look at later. It has to be 0 and 1. And the data also has to be, for naive Bayes at least, non-negative. Lastly, MLlib's models assumes that that dense feature vector is called features, and your target is called label. So these are kind of the things that you have to watch out for, and it automatically creates a prediction variable for you once you've done the prediction. So at this point, let me switch over to JupyterLab. And I've got, if you are following along on GitHub, I've got 2 notebooks in here. The MLlib classification, this one, just has the data pre-processing and the actual models. So we can have a look at that first. And once we've had a look at that, I'll switch to the other notebook that has the MLFlow tracking implemented in it. That will allow us to track the model characteristics, parameters, output, any other tags that you want to put in there. Quickly, I guess by show of hands or emoticons here, who's kind of familiar with PySpark or Spark? I only see one video, so I see like 1/2 a hand. And negative.
Actually, we considered, actually at IKE meetup, I think a couple of years ago, we considered PySpark on Databricks.
Nice, okay. So, like I said, PySpark really allows you to use Python code to interface with Spark. So what you have to do at the start is start a Spark session. To get up and running. The cause is somewhat misleading because it will actually always show one core for each of the distributed cores. And then PySpark is really a combination of many different things. So we've got SQL libraries that allow you to work with the data in a like a SQL-like way, I would say. And you'll see some of the things that are kind of similar. And then PySpark's machine learning libraries, which, like I said, today we'll be looking at. This is all numeric data, basically, but some of it are categories. So vectorizing those categories, scaling continuous vectors, and then assembling it into one dense vector. And as an example, I'll show you what logistic regression, a random forest classifier, and a gradient boosted tree looks like in PySpark with some cross-validation. So to load the data comes from UCI machine learning repository. And this is data of patients with heart disease, so with or without heart disease, different types of heart disease. And we've got some data on them, such as their age, gender, resting blood pressure, blood sugar, ECG, whether they've had any heart anomalies, and so on. And you can read in data and assume the schema, which is possible, but if you want to make sure that it works correctly, I would suggest defining your schema beforehand. So this is, you can see the kind of SQL flavor coming in. And this, defining each of your variable names, the variable type, and whether it can be null or not. In this case, I had to do it because there are some null values in here or some question marks. So I have to declare those null values. Otherwise, all of the fields were seen as a string type. Besides, after defining your schema, loading in this case, that's CSV, to a Spark data frame. So this is somewhat different to a pandas data frame. Like I said, it has this SQL flavor to it. And it's also the newer version of the Spark RDDs, or distributed data frames, that were originally around. And I find it a little bit easier to work with. You can call describe on your data frame and cast to pandas to be able to see your data. To pandas does read the data to memory, so I would suggest using this sparingly. It's all right with aggregated data, but I wouldn't suggest doing that on a big data set. Right. And so you can see we've got about 300 rows in this case, a few missing values, nothing that looks egregiously out of range. Everything seems like within a reasonable range. I can call group by on that data frame as I would do in pandas, for example. In this case, on our target heart disease. And you'll see that there are 5 different categories of heart disease, though typically for this data set, and what I've done here as well, is that people have split that simply into heart disease absent or 0 and everything else as present. And I've also done that because some of the models, gradient boosted trees in particular, can't do multi-class classification in Spark. So having a binary target allows us to evaluate them all in the same way. Some things are quite a little bit different if you're coming from a pandas environment, for example. So to get a count of missing data, it's a little bit like a case when statement in SQL. So when is null, get a count of that. And we can see that we have a few variables that have some missing values, not a lot. So I've just decided to drop those. And then I've labeled my feature columns features and heart disease as label. To create a new column, there's also somewhat more effort in PySpark. So you have to call your data frame and with column and give the new column name. And again, I've got this case when statement. So when heart disease is 0, the new column label will be 0. Otherwise, all of the other types I've just classified as 1. And I've just separated my columns into continuous and categorical, because for the categorical ones, we either have to one-hot encode them, or you can use PySpark's vector indexer, which tries to automatically essentially do that. In this case, I've gone with the vector indexer. And here's where that pipeline comes in. So for the pipeline, as I said, PySpark expects a dense feature vector. The vector assembler takes all of your input columns from my list of features and outputs a single feature, dense vector, as you can see here below. So we have one single feature category. I then called my vector indexer. So again, that kind of tries to automatically assign which variables are categorical to one how to encode them. And I've scaled my data to be between 0 and 1. Very similar to something like sklearn, if you're coming from an sklearn background. Once I've defined all of these, say, transformers, I can add them to my pipeline, the assembler, the indexer, and the scaler, and then call fit and transform on my data. As you would with sklearn. So to get a features and a label column of fields. And like I said, the labels here, I've just encoded to 0 or 1 from the original. PySpark has a model cross-validation, which I'll show in a moment. But if you just want a training and test split, at least when working with Python, the preferred approach seems to be just taking a random split of that data. There is a train test split function as well. But I'm not sure how well it's implemented in PySpark, so the Python flavor of Spark. So here I've split my data into train testing. And like I said, and I'll just jump to the bottom for now. I wanted to show you what logistic regression, a gradient boosted classifier, and a random forest classifier looks like in PySpark. So for each of these models, I've gone with the default binary class evaluator, seeing that we've got a binary target here. And by default, that tracks the area under the ROC. You can change that if you'd like. For example, accuracy is available. I think log loss is also available. For now, I've kept it with the default. We can specify a cross-validator, very similar to an sklearn. And for that cross-validator, you need to supply the following characteristics: the classifier that you're using, the grid of parameters over which it must test, which we'll look at the moment, how your model is being evaluated, and then the number of folds. And here I've just chosen 2 folds because all of these parameters take a while to train, but you should probably use 5 or more if you're doing this with real data. Fit model gives you information on all of your different models from the cross-validation with all of your different parameters. So you have access to that if you want to, but you can also call best model on fit model, and that automatically gives you your best model according to whatever evaluation metric you decided on. In this case, like I said, I went with area under the ROC. And you can transform your test data to get predictions, much like you would with sklearn, and evaluate those predictions. In terms of the parameters, much like with sklearn, you can provide a parameter grid of parameters that you want to test against. And MLlib documentation is pretty good in specifying exactly what you can change and what you can't change. So for example, some of the things that you can change for logistic regression are your regularization parameters and the maximum number of iterations. For random forest, the number of trees being built, the maximum bins split at each leaf node, and the maximum depth of those trees. Similarly with gradient boosted tree classifiers, you can specify things like the max depth, max bins and max iterations, and also the step size or your learning rate. And you can see when I run this, I just ran it with a few parameters. A logistic regression actually comes up on top. In this case, with an area under the RC of 0.9. Pretty good model. The gradient boosted tree, not so great. I didn't retrain over many parameters, so I think that just needs a lot more training. And I ran a forest, more or less the same as the logistic regression. So this is the flavor. This is obviously a classification example, but it's very, very similar for regression. Your metric would change, and again, you have a number of metrics to choose from. And you can cross-validate and run different models. Obviously, the parameters that are open to choose depend on the type of model and what hyperparameters there are to set. For models like logistic regression, you can also get some more model summary information, as you would with sklearn. So here, just running a logistic regression again with cross-validation, you can get a summary of that model. Again, here the best model, and get the coefficient matrix, the intercept. You can set the best threshold according to your evaluation metric for your model. And you can also see how your false positive rate and true positive rate changes over time. And here I've just printed out the first 10, I think, occurrences. So obviously it goes much higher. In this case, we can get our coefficients and our intercept and save that. So very similar structure to sklearn's pipelines, which makes it really nice to have PySpark available. Like I said, you don't have to know scalar to be able to do it, and it allows you to work with much larger data sets potentially. Probably for me, the biggest hurdle was getting used to the syntax around data merging, cleaning, aggregation, seeing that it's a little bit different to other tools that I've worked with before. I don't know if there are any questions here. Otherwise, I'm going to show you what that looks like with tracking.
I have one sort of just meta question. So are you using PySpark in any way right now in work projects or otherwise?
I've used PySpark mostly for NLP, actually.
Mm-hmm.
Just because I've got a lot of text documents that can get big. For other projects, I've not had a reason to use it. Unless you really have a lot of data, it's not really worthwhile.
Mm-hmm.
Yeah.
I've never entirely understood the value, because I feel like most of the time when you end up with such a large set of data, you can end up taking a sample and then you can do more complicated models and stuff like that. And you end up getting a better result than if you just did linear regression on a really massive set. but I haven't. I have very little experience with PySpark, so I don't know that I totally connect with the value necessarily.
Yeah, so that is an unfortunate thing about MLlib is that like the neural networks are pretty limited. And I think at the moment it's limited to like a multi-layer perceptron. But you can have more complicated models. I chose a more simple model like logistic regression because I figured most people will be familiar with it, or everyone will be familiar with it. It's a toss-up. I think the big thing comes in like what happens after you've taken a sample of your data set and now you have to apply that model to the whole data set.
Yeah. So
that's when it becomes useful.
Even on the NLP side, like is there a way to do like a transformer model or something like that within PySpark? Or do you know of a way to do that?
Not that I know of. No.
So I can add a little bit. I mean, I think Spark's been around for a while. So to a certain extent, some of these, companies that are using Spark, it was really before, like it was, you had like big GPU and GPU clusters that you could, readily use. But I think one of the other use cases why people have stuck with Spark is because, you saw that the Spark data frame looks a lot like a Pandas data frame. But Spark also has that sort of native streaming support where you pretty much don't have to change your code at all. And you can change it from working on a batch to working on a stream. And that's good for either training, if you're doing sort of online training, but it's also really good for doing predictions if you have sort of streaming data coming in and you want to be just in real time running predictions. So I think that's one of the areas that has Spark be a little bit sticky with companies as opposed to trying to build new streaming pipelines, potentially using, whatever. But I think I've seen stuff, John Snow Labs is talking about, what they can do with their NLP models. And then I don't know exactly how it works, but NVIDIA is working and they have built GPU accelerated Spark clusters, but I don't really know how much about those yet.
Yeah, that's a great point about the streaming, Ted. I think that's definitely okay. And the other thing is that I've done a lot of like processing of my data on Spark. And then if the model that I want to use is not available, I can export a subset of the data at that stage. The other thing that I wanted to show you, yeah, sorry, before I continue.
Do you deploy this model? These models, sorry.
So yes, we can. And that's one thing that MLFlow actually does really well, is that you can track your model and deploy it with like a single line of code. MLFlow, I should say, seeing that I'm talking about the two at the same time, is totally independent of PySpark and Spark. It works with Spark, but it also works with other things, sklearn, Keras, TensorFlow, PyTorch. And that allows you to deploy your models and keep track of them. You can have like a dashboard.
PyTorch works with clusters?
No, I think you misunderstood. Michelle's just saying that MLFlow is not just a Spark or a cluster thing. It works with lots of different libraries.
Yes. Yes.
Okay, it is just I was interested with your experience with natural language processing, because kids study language for many, many years to understand what is written in books. So I would assume that it would be helpful exactly for this kind of work. And that eventually you will need to work with data which is distributed on clusters just for NPL. Sorry, NLP, sorry.
Certainly with, as you say, like the size of text data sets, if you're thinking about like the Google Books data sets or all of Wikipedia, it gets very big very quickly. And that is when distributed processing is very useful. Yeah. So with MLflow, I say MLflow is really a suite that allows you to do a lot of different things. And I'll mainly show you the tracking today. I'll really only be talking about the tracking, but you can deploy your ML models. And you can track them. I have a dashboard of those models as well. And like I said, it's not specific to Spark. Even though I'm talking about both of them here in the same presentation. MLflow is open source too. It's maintained by Databricks, which always gives me confidence because you can see the source code, you can change it, it's not proprietary, and because it works with many different tools, it's easy to move between different tools. You're less likely to be stuck with one thing if you know one thing. And I was really enjoyed the ease of this. So I'm not an MLflow expert by any means, so feel free to ask me questions. I may or may not be able to answer. This is really the result of me also wanting to learn a bit more and discover MLflow to see whether it would be useful for me to use in my work projects. And I think my answer is definitely, yeah. I definitely want to start integrating this into my workflow. MLflow can log your get commit hash, start and end time of runs, the source, and then model parameters, metrics, and any artifacts or any output, whether images, notebooks. So I really like that you can track, for example, your model performance associated with a specific get commit. Because it's so easy to change something and then you don't know exactly where model performance changed. So I like that you can track all of that. And one easy spot, you can save this either locally, you can spin up a MLflow server, like I'm going to show you now, but you can also save this on a SQL database on SageMaker, on Azure, probably on other things as well, but I know MLflow specifically has integration with those two tools. And through the API, you can get a nice little dashboard as well to see, for example, competing models, the best performing model, how it's changed over time. Here it shows the total number of runs. So the workflow of MLflow's tracking is really that you create an experiment, you add a run or runs to your code associated with a specific model. And then, I don't know why I wrote view logs there, but you add the logs. Add logs for model metrics, model parameters, all of those things that I just talked about. So all MLflow runs are logged to your active experiment. think of this just as your logbook name. And you can set that in a number of ways. You can use MLFlow set experiment command to set that. And you can also reference the specific experiment ID in the run. And if no active experiment is set, runs are logged to the notebook experiment. Tracking API automatically writes the data locally to an ML runs directory. You can also save your models and save all of the information for the models so that you can deploy them very easily with MLFlow. And that's saved into an MLFlows directory. And to view the output of your runs, you can run or call the MLFlow UI from your terminal. And it opens up automatically on port 5000. It spins up a local server. So let's see what that looks like. Let me show you what the server looks like first. So these are the runs from that notebook that I just showed you. I just called this experiment SDML. And you can see that I've got my specific model, the percentage of training data that was used to train that model on the random seed set, and then whatever parameters I chose to log for a model, such as the maximum number of iterations, maximum depth and bins. All of the models don't have information on all of these parameters, depending on what was changed and what was logged. And I can easily sort, oh, sorry, I think I've actually closed this server. So let me just start that again. So MLFlow UI, and in my case, I specified a different port here because I've got MLFlow running, a different version of it running on port 5000 already. There we go. So I can easily sort by the best performing model, or I can search for models according to a specific parameter or a specific model name. A really nice way to have a quick look at all of your models and track them. And from here, I can also choose to deploy a model, any of these models. So let's see what that looks like. Same notebook, same models. The only thing that's changed is I've now added MLFlow tracking. So for that, you have to import MLFlow, and seeing that I'm using PySpark, I've also imported MLFlow Spark. Obviously, if you're not using Spark, if you're using this something else, you would use the relevant modules for TensorFlow or sklearn or whatever you want to use MLFlow with. It doesn't need to be with Spark. I've set my experiment name, which is that name that you saw in the browser. Start the client. And then I've just created a little function to create a run. It looks for the experiment names. And if it finds that specific experiment name, it grabs the index of the experiment so that it can save the information of a particular run to that experiment. In terms of what that workflow looks like I said, after creating an experiment, you would create a run. under your experiment name, because you can have multiple experiments going. And then you can add tags, parameters, and metrics. That's logged to that default location, which is an ML runs directory in your working directory. And when you're done with a run, remember to terminate the client. You can also call with client if you are worried about forgetting to terminate that client. This one is just a little example. You can see I'm just putting in fake numbers here, 999, just to show you what it looks like. You would say client set tag, give the run ID that's associated with an experiment. You can give your specific tag or parameter name, and then log the value associated with it. So what that looks like in an actual example, if we go back to our models, I've selected my model parameters here before, and now I can extract that models from my best model at the end of the cross-validation. And I've just chose to log a few specific things. In this case, max iterations, max depth, max bins, and the parameters that come in the form of a dictionary from that parameter map. So I can log my parameters according to the model. And you can log, in terms of the tags, you can log whatever you like. As an example here, I've logged the name of the classifier, which you probably want to have. And I've logged the random seed and the percentage of training data. So, if you want to try your model again, after it works with a different random seed, just to check that nothing is changing, you can do so, and you can compare your model performance. You can select other values of interest here. For example, the git commit, I think, is a very useful one. And similarly, you can log your metrics. So in this case, I'm logging my evaluation metric, which was that area under the ROC. And I can also save my model. And this saves the model information in terms of exactly what environment this was run on, package versions, and then model parameters. And MLflow can then use that saved model to deploy it either locally or to AWS, for example. And then it can take in data. I know it takes JSON format, it accepts pandas format, and there's a few other formats that it also accepts. So I didn't do that today as part of the talk. I thought that might get a little bit long, but know that that is available. So after saving that model, you can deploy it. And at the end, I've just terminated, again, my client. So with relatively very little hassle, a few lines of extra code, it's quite a nice way to keep track of everything.
Hey, Michelle, can I ask, have you used any other of the tracking tools, WNB or Comet or whatever? Do you have any, thoughts about?
I haven't. So unfortunately, I can't give you a comparison of them. I'd be interested to hear whether anyone else has used any of those ones.
The sort of the structure of like create experiment, create run, hey, log this chunk of info seems very similar between all the different technologies. So I know like WNB, they have a lot of UI for just viewing stuff, right? So not only did it record it, but if you want to see like a graph of, you know, something over time. And for, I mean, this is Spark, but so if you're doing deep learning, then it can also do like metrics per epoch. And so then you can see sort of your training progression and stuff. So I don't know if more,
same
yeah,
here.
if more of the difference is in sort of the pretty UI, not the base logging capability.
I suspect so, that it may come down to the pretty UI and possibly how hard it is to then deploy a model. That was probably the other thing that I would look at. As I said, I haven't used any of the others, so unfortunately I can't give a direct comparison, but I was pleasantly surprised at how easy this was to get up and running.
Do you know Scala? And if you do you find it helpful?
I do not know Scala, which is why I love PySpark, because it allows me to do the things that I can't otherwise do. I think it's incredibly useful. I see it coming up a lot in job descriptions. I think it's quite a specialized skill. So if you're really good at Scala, that is a very prized thing for employers. Because it seemed relatively specific, I've always stayed more broad.
Thanks.
I just want to say as a side comment, so my background is I'm a SQL guy. And so Spark has wonderful support for SQL. So pretty much any kind of pandas, data munging kind of stuff that you can do with SQL syntax. And so for me, there's certain things that are actually just much easier for me to think about. Again, because that's my background, much easier to think about in terms of a SQL command than in terms of functional, you know, type operations.
Same. Even if the commands look slightly different from SQL, you can still, the logic is the same. It's just about translating that syntax from SQL to PySpark SQL.
Yeah. In particular, right? I mean, like anything that you just do on a single table or whatever, you can do it in either. But nested subqueries in SQL, I find difficult to translate easily into pandas or anything else, right? And there's sometimes where you just have a subquery and it just, again, maybe it's because I'm a SQL guy, but it's just like there's just nowhere near as compact a way of saying that same thing in something like, you know, pandas or PySpark without using the SQL flavor of it. Cool. Well, should we open up the floor, just see if anybody else has any comments, questions, anything else they want to see again? We've got a few minutes, so if anybody wants to just ask a little more.
If no one else has any, I have one. So you mentioned the NLP stuff, so I figure that follows kind of a similar pattern. You might just do a different model, or do you do the same model, or does it do something to featureize it, or what have you done with that in the past?
Yeah, so very similar in terms of the pipeline structure, you know. I'll kind of call like a tokenizer, string to numeric vectorizer, get a term frequency or TF-IDF count, and then put that into a model. I've used mostly like clustering and naive Bayes on Spark. Like I said, they're like more complicated models like transformers or autoencoders, unfortunately, aren't available in Spark. But if you find that it's useful to wrangle your data in there, then you can always export your data at that stage. And it's very easy to change it into, for example, a pandas data frame, or just a text file, and then you can, get an NumPy array from there, like a dense feature vector.
So what kind of text data did you have that you had so much that it was relevant to use PySpark? Or was that just simply the format the data was in to start with, and so you continued using it?
Sorry, I missed that last bit, Ryan.
So you had so much data that it was in PySpark, and then you modeled with it using MLlib. Was that the format that the data was already in, or did you choose to put it in that format, or what was kind of the...
That was the data, that was the format that the data was already in. And it was a lot of, similar to what you're working on at the moment, a lot of emails that had to be clustered. They wanted to do topic analysis on it to be able to find relevant emails faster.
I think we have some questions in the chat. I don't know if I should read them off.
I've been chatting a little bit about SQL.
One of the things, I don't know if this is totally relevant to the question from Michael, but my understanding with things related to Spark is you kind of give it a series of commands, and then it does sort of like what it does in SQL, where it has some optimizer and it actually figures out the best way to distribute that task and do it efficiently and stuff like that.
That's why they encourage you to, as much as possible, use that kind of transformer encoder layout and avoid for loops as much as possible, and other structures that don't lend themselves well to distributed processing.
Mm-hmm.
So any kind of like group by and apply, for example, would also work better. Spark can natively break it down at the back for distributed processing much better than anything that you have to like loop over.
Mm-hmm.
That's my understanding. Ted, I don't know if you want to say more about that. I know that you've also used it a lot before.
Sorry, I was looking at this pandas query option, but it doesn't look like query supports SQL syntax. I don't know. The examples are, it's Python syntax. So like there's an example where it's like A greater than B or whatever, and it just does some kind of evaluation.
You can do similar things in Python, but they will look different. You need to use, quite often you need to use parentheses to work on your methods order, how they evaluate it. But, I mean, you can do a point, a dot, and another methods and such, but actually sometimes Python got confused and you need to use parentheses. So it will all work correctly in correct order.
This is just a very selfish question for me, but can I use literally ANSI SQL syntax and say, select bloody blah, join bloody blah, where bloody blah?
Python allows to call in I'm not sure about pandas, but Python itself has packages which allow to call SQL directly and to use SQL queries directly.
Okay, so it'd be a separate package.
I guess so. I know that it is possible. I didn't look it up. Sorry.
Yeah, no, it's okay. I can look it up.
Yeah. And the name escapes me now, but you can put SQL directly into Python and then interface with the SQL database.
Yeah.
And Rui asked, am I applying AI to neuroscience? Not at the moment, no, but I'm applying it to more I guess lower down in the body right now are the biological things. In particular, like I said, trying to detect whether someone is hydrated or not, to recommend whether you should drink water, or to help with people who are having kidney failure and they are on dilation machines.
You know, the interesting thing about Spark was the lazy evaluation. Ryan mentioned about it already, that when you do this pipeline thing and you stack a lot of, and not necessarily even in pipeline, you know, it could be previous commands. And somehow PySpark chooses the line of the most efficient execution and the shortest, which is rather interesting.
Yeah, so like a very naive example would be if you created a data frame with every column from your CSV or your Parquet files or whatever, right? And then you've got your pipeline and you do whatever, and you pull out these 10 features and you run some algorithm. If you string that all together, the optimizer is going to very quickly see that you actually only used 10 columns out of your data. And even though you literally told it, pull every one of those columns into my data frame, it'll optimize it and it'll just completely prune the unnecessary stuff, and it'll only pull the 10 columns from disk that it actually needs. So stuff like that, the optimizer. I haven't used Spark that heavily, you know, so I don't know what stuff it will and won't figure out, just like any other, you know, relational database, right? The optimizer tends to pick really good query plans, but it's not necessarily perfect. But something really simple like that, it'll just see, oh, you never used this, so I'm not even going to bother loading it. So that's pretty clever.
We've gone off the rails in the chat on
yes,
the pros and cons of drinking water.
I remember that whole incident. It's horrible. But I probably should drink more water than I do.
And we should all drink more water. And that's actually the biggest thing that I've realized since being on that project, is because I've also been measuring my water intake, and I've been not only the data scientist, but one of the guinea pigs. And I realized that I'm very often dehydrated.
I will say on the flip side that my brother once worked for a company that that worked on kidney transplants, without going all the details. But so he said that he's not a doctor, but he said all the research that he had to do because they were dealing with kidney transplant, he was saying that, you know, the whole idea of like, if you drink water, it sort of like flushes things, you know, out of your body. He's like, that's not how kidneys work. Like adding more water doesn't actually help like rinse stuff. Because of course, if it did that, then it would rinse all the good stuff too, right? You would lose your sugar, your protein, your whatever. So anyway, he made me feel less guilty about not drinking as much water.
There's a lot of myths associated with it, but I do know on the weeks when we have to test, when we're doing dehydration experiments, we are all cranky.
How do you, is there a specific measure? Like, can you empirically test someone and say you're dehydrated? Like a lab test?
There's a number of different ways to do it. Right now we're using urine because that's the least invasive. The other way is to get blood plasma, but then you obviously need to be in a hospital.
And so you're just checking like the concentration of stuff in urine?
Exactly. You could literally look at the color. The darker it is, the more hydrated you are. It's like what do you call it? Like a litmus test, or you can get like a little reader that tells you exactly what the urine, the osmolality is.
Exactly what I wanted to mention. In Israel, where they have problem with the hot weather, and you do need to be properly hydrated. They pretty much very well trained to look at the color of the urine and recognize are they hydrated or not.
My parents trained me to drink a lot of water when I was little. If we went to a restaurant, they would give me a quarter for getting water instead of soda or something like that. And when I was little, that was enough money to be an impressive amount. So I cut out soda and all that stuff very early and just drink a whole ton of water. But now I'm an annoyance at the table because I drink so much water and I need constant refills.
Would you be interested in signing up for an experiment?
It sounds like you're intentionally dehydrating yourself at some point, so I don't know if I'm as interested in that part.
Well, we need to check that it works. So we need to get both sides. As you know, you can't just see that it can detect hydration. It also needs to detect the dehydration. It's definitely better in winter to do. Also, water is way easier going than malaria trials.
All right. We're definitely far, far afield. All right. I think we've got time for one last question. If anybody wants to sneak one in before the bottom of the hour. At 1:30, we're going to shift gears and go to the project and data science coding questions. So anyone last taker? All right. Well, then let's give a virtual round of applause for Michelle. Thank you very much for joining us today. Really appreciate the presentation.
Thank you. It's been a pleasure. I hope it's been useful, and I'll join again.
All right, great. Well, let us know if you come up with any other interesting things you'd be willing to share with us. Hope to see you again.
Thanks. Bye.
All right, so as we shift gears, we're actually a couple minutes early, so we don't have to rush here. But Ryan, you've been talking with me about the data-oriented competition. Did you want to just chat about that? Were you planning to do a separate formal session about it?
I think it might be worth another session, a dedicated one, but we can at least have a conversation about it because I think that it actually might be something that lends itself well to a little hands-on tutorial time because we can train models in a minute and we can try some things and see how it works out. So we can discuss it some today and then have a separate session for it maybe next week or whenever available.
Okay. All right, cool. Well, I don't necessarily, we're usually running late, not early. So I don't necessarily want to like dive into something 2 minutes early if people are planning to join us at 1:30. So I'm not really quite sure what to do for 60 seconds.
I have a rather unusual offer. Let's do a break.
Wow, we never have time to do that. All right. So if you're not staying for this, thanks for joining us for the talk, and you're free to drop. And then, well, it's 1:29 now, but feel free to take a 1 minute or a 5 minute break. And then we're going to be talking about some different competitions and just doing Ask Me Anything questions about approaching projects and coding and that kind of stuff. So we'll take at least a 1 minute break here, and then and then we'll join back up. See if anybody new starts trickling in at 1:30.
I'm just gonna refill my water and then I'll be back.
Sounds good.